Sunday school class. Dr. Ross is away this week, and please help yourself to the treats over there. He will be back next week, and the week after, Ross Hoagland will be giving a talk here. So today we have a video from Reasons to Believe. Couldn't rope in a presenter, so we're going to do a video. It's very good. From Reasons to Believe. It's called part of the Stars, Cells, and God series. Specifically, it's 2 parts, Gullies on Mars, and Dave Sargent will be fielding questions on that. And the other half, earliest rope making. That's very important from an archaeological standpoint. Let's see. Okay. Thanks for everybody who brought the treats, and especially to Valerie and Maria for setting things up. We do appreciate that. And with that, let me say a prayer and we'll get started. So, thank you, Lord, for the rain we are getting here in Southwest U.S. Bless us, Jesus. Tune our brains and spirits to gain apologetic wisdom to help us be worthy witnesses for you. Bless Hugh Ross in his travels. In Jesus' name, amen. Okay, guys, you can start the video.
Welcome, everybody, to the latest edition of Stars, Cells, and God. This is the program where we describe new discoveries that are taking place at the frontiers of science and discuss how these discoveries provide evidence for God's existence, for God's character, and the reliability of the Christian worldview. My name is Fuz Rana. I am a biochemist and a Christian apologist, and I'm joined in studio today by Dr. Jeff Zweerink, who is also a Christian apologist and an astrophysicist. We both work for an organization called Reasons to Believe, which is the sponsor of this program. If you want to know more about Reasons to Believe, go to our website, www.reasons.org, or you can follow us on social media, RTB_official. Last but not least, go to our YouTube channel, Reasons to Believe, and subscribe, and then also use the notification button so that you are alerted the next time a new episode of Stars, Cells, and God drops. All right, well, let's go ahead, Jeff, and get started today. You're going to be talking about gullies on Mars, and I've got some new insights into when the earliest rope technology appears in the archaeological record. So, Jeff, go ahead. Take it away.
Well, to start off, I'm just curious. You know, you've been doing apologetics work longer than I have. I was just curious. Do you remember when you found out that Mars had water on it? What was your reaction to that?
Yeah, well, I remember at that time, the reaction probably was that this is a problem, right? Because everybody would have associated a warm, wet, early Mars with a venue where the origin of life could have taken place. Mm-hmm. And so therefore the attempts were to try to do anything we could to dismiss the idea that water was on Mars.
Well, I'm glad to know, because your response is very similar to my response. It was, I had this kind of, well, if God fashioned Earth, water's a unique property of Earth, and if we're finding water other places, maybe there's other planets where, so it was this kind of almost reactive, defensive posture about it. And, the nice part of doing apologetics work long enough is that you kind of have to force to deal with data and wrestle through things. And, one of the things I want to talk about today is these gullies. And gullies on Mars, or gullies on Mars is what I want to talk about. But these gullies are evidence that Mars had liquid water on it. Mm-hmm. And, I just remember initially hearing about these gullies or places, and I'm thinking, well, okay, maybe there's got to be some other explanation there. That's not water. Among the things that I've come to find amusing facts about our universe is that if you ask what are the most abundant molecules in the universe, not elements, but molecules, There's hydrogen, because it's
Right.
diatomic. There's a triatomic version of hydrogen, which is called the hydronium ion. And then the third most abundant molecule in the universe is water. And once I realized that, and then kind of got to thinking about things, also there's a scriptural insight. It's like, it just occurred to me that water is not really as fine-tuned and as designed as it is, the idea that there's water other places is not the crucial issue.
Mhm.
And that's what this discussion or this discovery on Mars is kind of highlighting for me, is that I think, yes, it's great evidence that these gullies were carved by water, and I'll get into a few of the details in a moment here. But it's not ooh, we got to get rid of this can't be, because that somehow impinges on Earth's uniqueness, if you will. And so,
Well, Jeff, I'm glad that you're actually bringing this point up, because in my experience too as a Christian apologist, sometimes there are these favored arguments that a lot of apologists like, that a lot of lay people love to hear about, that really aren't the best arguments necessarily, but they become pet arguments. And in my experience, when you actually address the data fairly and honestly, and you realize maybe these arguments actually are not good arguments, or they're not going to be effective or impactful, by thinking about the issues and the data a little bit more, oftentimes it leads you, at least for me, it's led to new arguments that actually turn out to be far more robust and far more certain, I guess, in terms of the science that undergirds them. So your point is a really powerful point that I think people need to take to heart.
yeah. Well, and what I found often with those arguments is that I wholeheartedly concur, is that often by thinking either one, there was an argument that it wasn't really relevant, if you will. But where, it hits at something, the argument that flows out is more robust, but it's more sophisticated, nuanced, less, well, this is just the way it is, I've proven type things. But it really is powerful when you think about it. And that's kind of what I find in looking at this discovery of gullies on Mars is, these gullies were found many years ago. They're nothing new. There are numerous signs of evidence of water on Mars. I mean, I can think of slides that I have. You've got little hematite nodules that are formed almost certainly in liquid water. You've got the formation of very pure silica deposits just under the Martian surface, which you get very pure silica deposits, most likely by precipitation from a water reservoir.
Right.
You've actually seen snow that's probably, it could be carbon dioxide, but maybe liquid water. But one of the landers, as it dug up, there were little ice cubes sitting there. So, I mean, the idea that water on Mars is a well-founded, robust body of scientific evidence that says, yes, there's water on Mars, and that water has become liquid and active at times. And, the mechanism for forming these gullies that are out there is, there's kind of two ideas that you had to wrestle with. One is, were they formed by water, where, and the challenge with that is that there's no way for ice or water to become liquid on Mars in today's conditions. And I'll get to that in a second. The other is, you've got an abundance of carbon dioxide that is solidified. And as things warm up, you could have CO2 sublimation happening, and that can move material around. And, there's numerous ways people have looked at that, but the final model, or the best model that stands out there today, is that you have these periods where the ice can become liquefied and carve out the bedrock. And then you have this kind of looser fitting material in there that has a bunch of carbon dioxide in there as well, and it will sublimate and it will move stuff around in there. And so, if you kind of just take a couple of slides forward, this, talking about gullies on Mars could have formed during periods of water ice, melting of water ice during periods of high obliquity. But the next picture you see, here's an example of those gullies where, that really does look like water's flowing down and carving stuff out.
Now, this would have to be a water flow over extended periods of time, right? Or could it happen quickly on the Martian surface?
So the best I can tell in terms of this model of what's going on is like, there are periods where for 15% of the year it could be liquid. So it could be repeated bursts of very rapid activity. But most likely this is not, flowing for tens and millions of years or something like that. It's the water liquefies, it carves things out pretty rapidly, and then the water disappears. Is the most likely model.
Okay.
Or on the scale of a few days, if you will.
Yeah.
But what you can see there, and there's a little inset where they say, all right, let's narrow in on this one gully, and you've got kind of pictures to the right, and the next image will blow it up a little bit more. But you see, on the top and the bottom, this is the same gully or the same image, and you see there's this, you can kind of see where there's a gully that's filled in with a bunch of junk, and then as you go down to the bottom, you see that junk has been cleared out and excavated. And so these are the sorts of, you've got this kind of fan delta type gullies up there, and these are on pretty steep inclines. And then you've got these places where things have been filled in and carved out or excavated, stuff like that. So this is the kind of phenomena that they're trying to understand. And the model they've come up with is that there are periods where the ice that is there, the water ice that is there, liquefies, does the carving of the rock, it gets filled in by stuff, and then the CO2 condensation sublimation is what kind of moves things around and does the smaller scale features. What's fascinating, what I find interesting, apologetically interesting about this explanation is that we've kind of got a mechanism to explain, a good mechanism to explain why this is going on, because among the challenges you have to solve in getting an explanation is if it's CO2, well, there are places where there's large swaths of CO2 on Mars and you don't see gullies. And so it can't just be CO2. So there's got to be something more complicated than that. There's a limit to how far north and south these gullies are and the elevations they are, which makes it challenging to explain, but it also gives you handles to say what explanations work. And so this explanation where you have water ice that's on Mars in the subsurface, liquefying, carving out gullies, things coming in, filling it in, CO2 sublimation and condensation, moving it around, matches all of the data of what sort of regions you'd expect it to happen, where they actually show up, where they see what elevations, and all of that, it matches very well. Now, the apologetic point comes out when you look at, okay, let's start to compare what's going on Mars and what's going on Earth. So let's look at contrast the two planets, because Earth has an abundance of liquid water on its surface today. Mars has virtually none today. And when you start just comparing the planets, and this is kind of getting into that more robust argument, it's not just, is there liquid water? It's, what are the conditions surrounding the liquid water? It's not just that, it's a bigger picture, because to get liquid water, you got to have the conditions where liquid water could exist. On Earth today, our temperature, average global temperature, is about 290 Kelvin, which if you translate into Celsius, is just over 15 degrees Celsius. It's actually 17 degrees Celsius. On Mars, the average global temperature is 210 Kelvin, 80 Kelvin colder, so minus 65 C. No way you're going to get liquid water out of that. Coupled in with that is that the pressure on Mars, because Mars is a smaller planet, the atmospheric pressure on Mars is much lower as well. That's a little caveat. Generally, smaller planets are going to have lesser atmospheres.
And this is because you're not getting gravitational retention of gaseous molecules? Is that why?
It's related to that, yes. And it's a little more complicated, because even though Venus is a little smaller, it's got a much denser atmosphere, because its atmosphere is carbon dioxide, which is a heavier gas than oxygen and nitrogen, which is, so it's a little more complicated than just size of the planet. It's related to what gases are there. But the atmospheric pressure on Earth, depending on what kind of units, and this is what I loved about high school chemistry, is remembering all the conversions. It's 101.3 kilopascals, which has absolutely no meaning to most people, or 1 atmosphere, or the more common unit is 760 millimeters of mercury, or I like to, torr, millimeters of mercury and torr are the same. So I'm going to use the torr. So 760 is atmospheric pressure on the Earth, and anything below that is less than. And so on Earth, we're 1 atmosphere, 760 torr. On Mars, the atmospheric pressure is 5 torr, and it's linear scale. So we're 760 torr on Earth. On Mars, it's 5 torr. Now, to give to give you a feel of how low pressure that is, the top of Mount Everest, which if you put humans up there, start to slowly die because there's just not enough oxygen up there, is 250 torr. So pressure at sea level, pressure at Mount Everest is 1/3 of sea level. We're under 100th. Mars atmosphere is 100 times less than atmospheric pressure on the surface of the Earth. And so again, it just kind of illustrates, yes, Mars may have water on it, but there's just more going on. It's not just about the water, if you will. And I think I was working through the calculations, and the equivalent pressure, atmospheric pressure to Mars on Earth is at 36 kilometers up.
Oh, wow.
The reason why I find that number interesting is we're flying a balloon out of Antarctica in 2024, project that I'm working on called GAPS. And we're floating, my experiments in the lab are to test all of our electronics down around 5 torr, which is 120,000 feet up. This is the atmospheric pressure on Mars, is what I'm testing, which I consider a vacuum, and for all intents and purposes, it is a vacuum. That's the sea level pressure on Mars. So that introduces another difficulty because, okay, if the temperature on Mars is 65 degrees below zero, minus 65 Celsius. Yes, how could water ever be liquid? Well, as the pressure goes down, your boiling point,
melting,
wherever it goes from liquid to solid, that temperature also goes down.
Oh.
But if you get too low, or if you drop the pressure too low, you get down to the triple point of water, where water can exist in solid, liquid, gas form together. But below that, you can have water ice, but when it warms up, if it's below too low of a pressure, when it warms up, it just sublimates. Yeah. It goes directly to gas. And the pressure on Mars is below the triple point of water. So it's not just simply warming it up a little bit. You can warm it up, but all that would do was cause the water ice to go to steam. That's not going to cause the gullies. So you can kind of see that even though we're talking about water on Mars, we're talking about it's not like, oh yeah, this is where life's going to thrive. It's a very challenging environment. So the explanation they got to of how you can get the liquid water is a couple of things happen. We've seen that Earth's temperature is larger than Mars. Earth's pressure is larger than Mars. Well, Earth also has a obliquity, or that's the tilt of Earth's rotation axis compared to the plane of the solar system. So if Earth's obliquity was 0, we would have no seasons because the Earth rotates and you're going to get the same thermal exposure throughout the year. But because Earth has a 23-degree tilt, I think it's 23.5 right now, you get seasons, northern and southern hemisphere. Well, Earth's obliquity varies between 22.1 and 24.5. So, just over 2.5 degrees, if you will.
Right, and that's supposedly one of the design features of Earth, too, is not only the obliquity, but also the stability of the obliquity.
Exactly. So Mars has an obliquity of about 25 degrees. So, okay, very similar to Earth, except we have reason to think it varies much more rapidly. In fact, we think that it can go all the way out to 35 and larger degrees.
Okay.
And so we see evidence of that happening over the history of Mars. The last time was about 630 million years ago where it did that. But if you say, all right, what happens to Mars when its obliquity goes from 25 out to 35 degrees, what you end up getting is more solar radiation on the northern or southern hemispheres, depending on time of the year, which will mean it will do two things. One, it will cause a lot of the CO2 to sublimate, which can potentially drive the atmospheric pressure on Mars up above the triple point of water. And you get additional heating, which can drive the temperature of Mars above the condensation or the liquid. Hate that when I lose the scientific term, where it can now go from solid to liquid form.
Right.
And so they can say, all right, they ask, how often can this happen and what elevations would you get it? And this model works where take Mars, largely in its same composition today on the surface, go out to 35 degrees obliquity, you're going to get an increase in atmospheric pressure, you're going to get temperatures going up, you're going to get water melting, carving out gullies, filling it with this stuff that can be less compressed, and it'll now move around when the CO2 sublimates and condenses. Great. To do that, to get liquid water on Mars requires this incredibly large obliquity variation. So yes, we got water on Mars. But when we now ask the question of how do you get water on Mars, it's like, okay, this is a way that makes a planet virtually uninhabitable because you've got huge atmospheric pressure swings, large temperature fluctuations, large fluctuations in obliquity, solar insolation, and magnetic fields, all this sort of stuff. If Earth's obliquity changed that rapidly, that would be pretty catastrophic to life on Earth. And what we see is that just happens pretty frequently on Mars. And so what I thought was kind of a threat, oh, we're finding liquid water on Mars. It's like that gave us the tool to go in or to investigate what are the conditions for it being liquid. And we see, wow, Earth really does stand out in its capacity to have liquid water and how robustly it has liquid water.
Right.
Living in a universe where liquid water is the third most abundant molecule in the universe. And I just found that reassuring. Not that this particular discovery, I've had enough discoveries like that where it doesn't bother me, but this just really does highlight, it's not that liquid water is the key criteria, it's that what are the conditions that allow that to happen in a robust way. It's not like Earth doesn't need these extreme conditions to get occasional liquid water. It just abundantly hosts an abundance of liquid water throughout the last 4 billion years. And that's an incredible thing, which I think is a very robust argument that Earth is fashioned and designed for us to be here. Not because it's the only place with water, but because it's of all the conditions that are required for liquid water, it really points to a mind behind designing it, not just, there's some of these around, we happen to be where it was lucky.
Yeah. Well, and to me, it's also a bit eerie to think that, water is such an abundant molecule in the universe, and it has, these highly unusual properties. I mean, the properties of water as a chemist are unexpected, right? They are highly anomalous, unexpected properties, but it's those unexpected properties that are precisely the properties that make water so useful for life. And there's, just catalogs of properties that water possesses that contribute both at a macroscopic level, but also a microscopic level for life. So that's also, kind of, I think, part of that argument may be a bit tangential, but it's still part of the case, right?
Well, it is. And I mean, even to throw a little bit more into that, I mean, I know enough chemistry to know what you're talking about in terms of water's remarkable properties, but carbon has that same sort of, wow, this is a really incredible element.
Right.
Carbon, hydrogen, and oxygen. Those are the three elements you need for these incredibly remarkable chemicals or elements or compounds. Our universe is structured so that outside of helium, which is an inert gas, hydrogen, carbon, and oxygen are the three most abundant elements in the universe, which from a mass perspective makes no sense because you would expect hydrogen and then helium and then lithium and because by mass that's what you would expect. But the mechanism of forming these elements in stars now makes it so that carbon, which should be the sixth most abundant, and oxygen should be the eighth, actually turn out to be in the top four.
Yeah.
It's almost like the universe is designed to support life. That's the argument I make, is that the universe is designed to support life.
Yeah.
But there needs to be these additional things so that it all works out on a planet as well.
Yeah.
Which points to a fine tuner or a designer for me. So.
Yeah. Yeah, that was a lot of fun, Jeff. Thanks. Great job. I'll go ahead and kind of shift gears, and we'll go from Gullies on Mars to hopefully a case for human exceptionalism. But just for fun, I don't know if you can. It's not much of a quiz, by the way, or game. But can you tell what all of these different technologies have in common?
Well, the fact that you told me we were talking about rope, I'm guessing it's because they all have rope in them.
Yeah. Well, there we go. So
I would have struggled with the bow and arrow had you not said that, though. I mean, what in the world?
But the point here is that we probably were so familiar with ropes and strings, really cords, right? That we take for granted just how revolutionary cord technology actually is, because not only can you use cords then to produce other things like baskets and nets and traps, but you can also use it to make composite tools. So, for example, a bow and arrow would be an example of a composite tool, right, where you're using different materials, combining them to produce a new type of tool, the spear there, where the cord is being used to attach the spearhead to the shaft, or even like a hut, right? It's the ability to attach the different branches together that you're using for the structural, architecture or the structural support, is actually, again, possible because of cord technology. And so there's a lot of interest among anthropologists as to when does cord technology actually show up in the archaeological record. And the problem, of course, there's always that problem is that cords are produced from plant fibers.
Right.
And so because they're biological materials, they degrade quite readily.
Right.
So the likelihood of finding, cord technology or fibers that suggest some kind of, thread or string or rope is virtually, unlikely to take place. So what, archaeologists do is they look for indirect evidence. Seeds are one of the more durable parts of a plant. So archaeologists will go to sites where there are tools, and they'll look for seeds that are from plants that would be useful to strip away the fibers and produce string or cords from them.
So if you were to find a place where there's just a whole pile of the same kind of seed,
like bamboo seeds,
that might be indicative of, okay, they're gathering the stuff, they discard the seeds and use the plant for a rope or a twine. Okay.
Yeah, that would be the idea. Or, if you have stone tools, do you see any kind of evidence on the tools in terms of the wear patterns that would suggest this was being used to produce, fiber, processed plant fiber for cord technology? Or you can even look at artwork. Do you see evidence for the use of cords in the artwork?
Like where they'd be drawing something that would be a cord. Okay.
Yeah. Or is there a depiction of a bow and arrow, in the artwork or that type of thing? And so there was the latest installment in trying to make sense of when cord technology appears was published recently in a journal called PLOS One by an international team of scientists, including a number of scientists from the Philippines. And what they discovered is that in a cave system on the island of Palawan in the Philippines, a number of tools that look like these tools show evidence for fiber processing, plant processing of fibers. And they date, somewhere between 39 and 33,000 years ago, which says that in the Philippines, approximately 35,000 years ago, the people on those islands were producing cord or fiber technology, which is really, quite significant. But this...
So, just as a quick little detour here, maybe tell me if this is... That's kind of a tough age range to date in. How are they dating that? Do you know?
I do not know off the top of my head. It might, you could probably push carbon-14 dating to that point.
Yeah,
but
that would be kind of
yeah,
out at the edge of what you could do.
yeah. Off the top of my head, I don't
Right,
know
okay.
how they and I don't and they didn't discuss the dating in the paper.
Very good. Okay.
So this is a cave system that's well studied,
Okay.
where there are layers that in the cave where people have gone in and have dated the layers, and so
Gotcha.
that's just then utilized as the
Very good. Okay.
right. So, but yeah, I'm not quite sure how they would have dated those layers, but this is just for the sake of completeness, showing in the inset the Philippine Islands. There's a huge number of islands that are part of the Philippines. Apparently, somewhere I saw a statistic, and it was a ridiculous number, And then one of the larger islands is called the Palawan Island, where there are indigenous people on this island called the Palawan people. And this factors into this study because this study actually is a beautiful example of marrying archaeology with experimental archaeology, where you go in the lab, try to reconstruct, the features on the tools as a way to help interpret it, plus kind of an ethnoanthropology.
Okay.
It's just a really, really beautiful study because one of the researchers learned how to process plant fibers from the Palawan people. Mm-hmm. So they spent time kind of embedded in the life of these indigenous people, and they will use bamboo fibers to make baskets and nets and things like that. And they utilize stone tools as a way to do this. And so this researcher learned those techniques and then took red jasper and fashioned it into a similar type of tool that they found in the caves, and then produced essentially cords with those tools.
That's someone who's committed to their work. I mean,
yes,
that's not a trivial task.
Right, and so and there were a handful of tools that showed micro polishing, some micro scarring, these brush-like striations that they assumed came from, again, processing plants.
Okay.
And they then
so these are not tools that are used with rope on them. These are the tools that would be used to process plants to make the rope.
Yes, exactly. Thanks for that clarification. And so what they're doing then is comparing, the micro scarring and the polishing on the red jasper tools that the researcher used to the tools that they recovered at the archaeological site, and showed a really good match, which now indicates, that about, somewhere between 33 and 39,000 years ago, the indigenous people on presumably the ancestors of the Palawan were actually making cords. Now, indirect evidence. Now, what this does, though, is find support from the recovery of bone fish hooks on the Palawan Island that date at 30,000 years in age. So if you're making fish hooks, presumably you've got cords.
Yeah, you're not out there dangling over your hand.
Right.
Or not catching any
Right.
fish if you're doing that,
And so, but then when you also look at, the Middle East and Europe for, what is the evidence for cord technology? Well, there's actually cords that have been recovered that are 20,000 years old in Israel. There's a site called the Ohelo 2 site, which oftentimes is submerged in water. And that actually turns out to be an advantage because it helps to maintain the preservation of soft materials.
Right, okay.
And so people have recovered direct evidence for cord use at 20,000 years ago in this site. But in other places in Europe, there's indirect evidence. So, for example, all clustering in the roughly 25,000 to 35,000 year range, there are these what are called Venus figurines that are connected with the Gravitine culture, which shows evidence of rope on or there's a rope around the Venus figurine, right? So presumably there's cord technology. People have discovered clay that have these negative imprints in I think a site in Czechoslovakia that looks like that imprint was made by cords of some sort. And then there's also the recovery of plant fibers from another site in Europe, again in that same ballpark range. And those fibers show evidence of fungal damage and insect damage. And that species of fungus and those species of insect actually attack textiles.
Oh, okay.
And so the assumption here is that these fibers probably were part of the remnants of textiles that recovered. So what you end up seeing here, when you look at this discovery in the context of a larger archaeological record, again, almost all this evidence is indirect, is that it looks like at about the same time in Europe and in the Philippines, modern humans were producing cord technology, which means most likely they had that cord technology before they even began migrating out of Africa. That would be the inference that you would draw, because the migration would have been into Asia, then into Europe, and then of course from Asia into Polynesia. Right. So that this would be a later wave of migrations. And so it looks like, because you're seeing indirect evidence in different parts of the world, collectively it looks like, okay, before humans were migrating, they must have had that technology. And there's
what's the time scale on when the migration happened? I mean, assuming
50 to 60,000 years ago.
50 to 60. Okay, so the fact that we're seeing it everywhere at 30-ish thousand, it's actually, that's, if assuming it happened before the migration, it means it's there actually 30,000 years earlier. Than
because really this cord technology in Polynesia, in the Philippines, is actually slightly older than what you see in Europe, right? And so you can't. It's hard to argue that this is some kind of cultural diffusion of technology. That is probably an inherent understanding of the technology before the migration took place. Those are the two options that you really have. It's interesting because in a site in Morocco at about 80,000 years in age, people have recovered beads with holes punched in them, where the microwear in those near the holes suggest that these were used as a necklace. Similar kind of discovery in the Blombus caves of South Africa at about 70 to 75,000 years in age. So you're getting a picture that is consistent with the idea that this cord technology is actually a pretty ancient technology with respect to modern humans. Now, what's interesting is that this pattern of distribution is very similar to the pattern of distribution you see for artistic expression. So we have evidence for cave art in Asia that's older, slightly older than what we see for the cave art that's in Europe. This is now in the 40 to 45,000 year range. And we also have evidence for symbolic expression in the caves of the coastal South Africa that are in the 80,000 year range. And there's even an argument made, though it's again an argument, it's not really evidence, that maybe even artistic expression was already present in Africa close to 120,000 years ago. So the fact that you see the archaeological record for these two independent features kind of overlap pretty significantly suggests that the earliest modern humans had symbolic expression, but also had some sense of a mathematical understanding, because the argument is from anthropologists that if you're able to take string or fibers and weave them into cords, there is a pretty sophisticated understanding of the properties of materials, how to enhance the tensile strength of those materials, right? The selection of materials that would have the flexibility to be used for cords. And again, that weaving pattern suggests some kind of intuitive mathematical understanding to produce kind of that weave pattern. That's the argument that's made.
And I'm curious about that argument, because there's part of me, I'm just sitting there thinking, to me, it's not a stretch. Somebody, you're looking along there and, okay, I've got this thing, whatever I'm using to pull something. Oh, that didn't work. Oh, I put two on there. somehow it gets twisted up and wow, that actually works even better. So I mean, it's not clear to me the connection with the higher mathematical part of
Right.
it.
Well, I mean, it's not like you're doing tensor calculus, right? But
Yes,
but there is an understanding of the fact that you have that by combining three fibers and then by weaving them together, it's maybe more of a geometric understanding
Fair
than
point, okay.
than mathematical,
Okay.
right?
But so it's the geometry mathematic part is not mathematic as in doing calculations, but mathematical as in, okay, we're
Right.
multiplying.
And you're using some kind of foresight, right? Right, in mental time travel to develop that technology. And so for me, this is, part of the case that I would try to build for human exceptionalism. In that, as from a Christian perspective, I think, Adam and Eve, or the descendants of Adam and Eve, were modern humans, anatomically and behaviorally modern humans.
Right.
And you see the appearance of anatomically modern humans in the fossil record about 130,000 years ago with regard to the unique skull anatomy.
Okay.
That's about when you begin to see that, the skull and facial anatomy combined. And, presumably the globular skull, which is unique for modern humans compared to even Neanderthals, allows for an expanded parietal lobe and allows for an expanded cerebellum, which are the parts of the brain in which information is integrated. The information in the brain is integrated, which is believed to be necessary for language and for math. And so you see these brain structures that presumably give capabilities that would be unique to modern humans, that are connected to symbolic expression and manipulation of symbols, and that the archaeological record seems to affirm that the time frame in which this behavior appears is very close to when we think modern humans appear.
Right.
And so you get a nice fit of evidence from the fossil record and the archaeological record that paints, in my mind, a coherent picture. Now, as Christians, we take the view that humans are uniquely made in God's image, and depending upon your particular view of what the image of God is, I take a view where I see the image of God as referring to certain qualities or properties that we possess. You would say that humans would uniquely possess those properties or those qualities. And if that's the case, then, there should be something that causes us to stand out. And I think that symbolism and advanced cognition, abstract thinking are those qualities that define the image of God. So this is a study that gives, in my mind, affirmation to that whole model that we're producing at Reasons to Believe.
So, I mean, obviously, we've talked enough to know, that I agree with your position on that, but it does seem like there's a correlation causation question in there, in that, the fact that you're seeing these anatomical changes corresponding to the increased intellectual capacities,
Right.
Whether physical causes can give rise to those intellectual capacities is a different question. But could you not make an argument that, there's something genetically that happens that provides the physiological changes, and the things that we see as the image of God are just the natural outworking of there's a new set of tools that we have to work with. And so it kind of gives a naturalistic naturalistic description of the evidence you're describing.
Yeah, and that's a great point. In your first point is spot on. These are correlations. These are not cause and effect relationships, though it isn't unreasonable to think that there probably is a causal connection between, expanded regions of the brain, that we understand what those regions do, at least in a general sense, and also seeing at the same time now, certain features in the archaeological record that not only suggest, but really strongly point to the capacity for symbolism and mental time travel and that type of thing that would undergird technology development. And of course, we're also making another correlation between this idea of, the image of God being qualities and that we see those qualities. I mean, I think the image of God is indeed an immaterial aspect of our nature, but I also would argue that there's got to be some kind of physical structures in the brain that allow for that immaterial aspect of our nature to be manifest, or that it's this very complex interplay between the immaterial and the material that's contributing to a quality that we would call the image of God, which again is ill-defined in Scripture. So
would it be too much of a stretch to draw a parallel back to our discussion about water, in that, as we're sitting here talking about it, that from a naturalist perspective and from a theistic perspective, it seems like both of us are going to expect that there's going to be a correlation between the physical changes and the intellectual changes that go on.
right,
So that the idea of physiological changes is something we're both going to predict or expect.
Right.
That's no longer a discriminator in the model.
right,
That kind of shifts the question to now, like with water, it's not, is there water? It's like, the question is more sophisticated. Does this point to the stability of a planet that can host life? Do the physiological changes you're talking about lead to the conceptual differences of what we're saying humans have?
yeah,
To have a new capacity, you're going to have a physiological change. But just because you've got a larger globular brain, does that mean that you're going to get the capacity to time travel, and symbolically?
yeah,
These are questions. I mean,
yeah, and
how do we distinguish between these two?
yeah, and those are fair questions. And once you start talking about how does the immaterial interact with the material, those become questions that are almost impossible to probe scientifically.
That's a fair point.
Yeah, so to me this is a great discussion because it helps to clarify. Because for me, what we're trying to do is say, is it scientifically reasonable to think that human beings uniquely bear God's image, right? And that we stand apart from all other creatures, and so, it is interesting that humans have a unique brain anatomy, right? And that unique brain anatomy allows for, higher cognitive capabilities, including symbolism, right? And that, if this is a quality that humans uniquely possess, that at least says that humans are exceptional in some way,
Right.
that aligns with, how we might understand the image of God. So it's again, it's a bit of a house of cards,
Okay.
right? But in other words, you're trying to make a case that it's completely reasonable to think that, again, human beings are exceptional in the way that Scripture seems to describe our exceptional nature as image bearers.
So I guess maybe it's a little less a house of cards. And can you build a coherent case that what Scripture is describing
Right.
matches the physical world?
Yeah.
Which is, it seems like you can say we want to do lots of things. One of them is, can we build a coherent case? And this seems an abundance of evidence as yes, which is different from saying, can we exclude other explanations?
Right.
Okay.
Now this is where, now that we've gone through this great discussion, this is where things get a little messy, because that's the nature of anthropology.
All right.
Is things get really messy. But this is an image of presumably a small piece of string that was published in 2020, right as we were going into the lockdowns. And this was claimed to be string technology produced by Neanderthals.
Oh, okay.
So if Neanderthals are producing cord technology, then, does that mean that humans really aren't exceptional, that this capability isn't really unique to humans?
Gotcha.
And this was...
So it wouldn't negate the idea that there are fascinating things about developing this. It would just simply say this no longer becomes something that we could point to that says, humans are unique
Right.
or exceptional from other animals.
Right.
Okay.
And so this was this is a small piece of plant fiber that was attached to a blade that is characteristically produced by Neanderthals. And this is from a cave site in France, and the date was about 40 to 46,000 years. So this is about the time where Neanderthals are on the cusp of going extinct. This is also about the time where modern humans start making appearances in Europe. But you can't arguably attribute this to humans because it is in a site that, again, appears to be exclusively a Neanderthal site. There's no evidence for modern humans in this site.
Okay, so in principle, I mean, I could imagine, human comes across, finds a Neanderthal blade. Hey, this is easier.
Right.
Just throws the rope on it.
Right.
But that doesn't apply here because there are no humans in this site. Okay.
Now, there's some things that are, and so the claim here is like, look, Neanderthals were engaged in producing core technology well before humans were, modern humans were, and they might have had this understanding of mathematical relationships and things like this. They had this sophisticated ability to produce technology. Now, the size of this plant fiber is 6 millimeters. And the diameter is 0.5 millimeters. But there is this, looks like these 3 fibers that are wrapped around in a right-handed manner and in a left-handed manner. The right-handed is called the S, the left-handed is the Z, a Z twist.
Okay.
And again, so the argument is, wow, this looks like, Neanderthals had invented string technology. And in fact, the researchers even did an FT Raman spectroscopic analysis of it. And it's an analysis that gives you information about the chemical composition of the material, or gives you insight into the chemical composition. It measures the presence of chemical functional groups, the technique. And you can see clear bands that indicate, and so the banding pattern is a fingerprint for a material. So you see spectral features that indicate cellulose was present as well as lignin, which affirms that this is actually plant fiber, that was being weaved, and that the types of spectral features you see would be broadly consistent with maybe the types of plant fibers that would be in the area at that time. Typically, plant fibers are made up of somewhere between, I think it's 70 to 90% cellulose and 10 to 30% lignin.
Okay.
Now, one of the things that's interesting, though, is that lignin is much slower to decay than cellulose, so that over time you would expect actually less cellulose in the plant fiber and more lignin. But when they recorded the FT Raman spectra, the top one is the sample, the string, and the other two are different types of plant fibers. What you end up noticing is that the cellulosic bands actually are more prominent than the lignin bands, which is exactly the opposite of what you would expect if this was actually a sample that was 40,000 years ago. So I question whether or not this is actually an authentic sample that's 40,000 years old.
Right, okay.
Also, at the site, they discovered other pieces of plant fiber, but only one of them showed this apparent twisting pattern. And so you have to wonder, is this just simply an outlier where that twisting pattern is absolutely accidental, right?
Well, yeah, the fact that it was the two different directions, that would at least be hey, maybe this is something where you got two pieces of rope and it's just getting twisted, because
yes,
I could see mechanics.
Right, and it's such a small piece.
Yeah.
And again, the spectral data doesn't fit what you would expect it to be.
Gotcha.
So to me, it's like, okay, yes, I can see why people would make the claim that Neanderthals were producing string technology, but the case is not far from robust.
Right.
And there's other interpretations that are less, maybe less sexy from an anthropological standpoint, but
Right.
But actually might fit the data better. So I don't think it's well established at all that Neanderthals were making string, though it's very interesting to see how many people will actually cite this study and just make this blanket assertion that there's clear evidence that Neanderthals were producing string.
Right.
You know, this has been my experience with all the claims about Neanderthals having comparable cognitive abilities to humans, whether it's art or music or, you know, you have it, is that when you actually examine the evidence that's being used to bolster those claims, the evidence is far from compelling, right? It's
Yeah.
you know, and it's usually one-off evidence. It's not like you've got, with regard to like the evidence for, you know, early modern humans, making cord technology, where yes, indeed, you have indirect evidence, but it's a plethora of indirect evidence that all coherently points to the same conclusion. It's not just a one-off piece of evidence. Whereas with Neanderthals, this is a one-off piece of evidence that, you know, that I would argue is imaginatively interpreted that Neanderthals had string technology. So.
Well, and to your point of just the messiness, there's, at least in my assessment, you would kind of expect the Neanderthal technology to be more primitive, smaller, less frequent, and probably less preserved just because of the time span and everything. So I could see where you look and say, okay, this is the kind of evidence we would expect because we just expect to see occasionally or whatever. But you're getting down into that range where it may just be the odd physical condition that let it come. I agree with your messiness part.
Yeah. Well, you know, but, you know, something else too that, you know, is, you know, I think interesting that factors into this is, you know, going back to the brain structure, you know, the brain structure of, you know, of the Neanderthal brain is different from the modern human brain in a way that you would anticipate that Neanderthals didn't have the same cognitive capacity. And this isn't my conclusion. This is the conclusion of at least a significant number of anthropologists. You also see, you know, genetic evidence that says there are differences in genes between humans and Neanderthals for genes that are known to play a critical role in cognitive development or that are involved in neuropsychiatric disorders.
Okay.
So, you know, so you got this, you know, you've got other evidence that suggests, but that maybe Neanderthals didn't have that cognitive ability. You know, plus, you know, when you look at the trajectory of technology for modern humans versus Neanderthals technology appears to be largely static. So when you put it all together, I think you're really hard pressed to say Neanderthals were just like us, right? Yes. Or that they somehow represent a challenge to this idea of human exceptionalism, you know, which again, you know, we see has an intriguing potential connection to the idea that humans bear God's image.
Right. No, I think that's an important and profound point, that there's nothing in there that says that humans aren't exceptional. You know, this to me goes to the discussion we were having during the human exceptionalism conference that we just hosted is human exceptionalism, it's there. Is it the precursors so that it can develop, or is it something that fits more, you know, more like a God put it there type thing? And that's a fascinating question that I could imagine it's going to take us a long time to sort out. So.
Yeah. But, you know, it's worth engaging because, you know, if you can truly show that humans stand apart in some way that you could, you know, connect to the image of God, you've got a very powerful argument for the biblical view of human nature and human identity, which goes a long way towards, I think, establishing the credibility of not only the Christian worldview, but the gospel.
Agreed, wholeheartedly.
Yeah. All right, well, Jeff, thanks. I've truly enjoyed our time together today, so thanks a lot. And thank you for watching this episode of Star Cells and God. We would love for you to enter into the conversation with us. So please go ahead and take the time to enter your comments, your thoughts in the comment section below. And remember, if you are on our YouTube channel, to subscribe and to like, not only like this video, but also set the notification so that you will be alerted the next time a new episode of Star Cells and God drops. Also, you can subscribe to Star Cells and God on your favorite podcast app. And so until next time, remember, the more that we know about science, the more that we have reasons to believe.
Okay. Thank you, Fuzz and Jeff. What we're going to do is we're not going to go up front. We're going to, if you have a question, come on back here, speak into the mic, and Dave or I will try to answer it, or one of you in the class can have a shot at it, trying to answer it. So first of all, I have one question for Dave here. Jeff indicated that the Martian gullies result from short periods of water liquefaction and some CO2 sublimation, followed by gradual movement of surface material. Does Martian wind contribute to this also?
Yes, the wind is a major factor. A couple weeks ago, I talked about Mars and talked about these global dust storms. And Mars has seasons, just like Jeff talked about. And the polar caps on Mars are pretty much almost dry ice, frozen dry ice. 14% of Mars' atmosphere is frozen at the poles. But during their season, which is about 1 year, every year, Earth year, the pole completely melts. And so all that dry ice melts and it rushes to the South Pole. So you get surface winds of up to 70 miles per hour, about an inch over the entire surface of Mars. Mars has such low gravity, just as Jeff talked about, that a lot of dust gets up in the air. So this is not uncommon. I would say this is probably like the 5th time I've heard about rivers and gullies on Mars. And every time water is brought up as a possibility of what caused these rivers and gullies and things. And then the conclusion afterwards is, oh, it was wind-made. Jeff did a good discussion about why we can't have liquid water on Mars. So there's just no way that the water could have flown that distance. Because the water would evaporate before it got to the bottom of the gully. So we have to eliminate water as the possibility because of the length of the gully. If you had a gully that was very short, that's a little bit of a possibility, but Mars is just too dry and doesn't have enough water to produce these gullies. A 70-mile-an-hour wind can cause a lot of erosion, and so a lot of these gullies that we see there could have been erosion from wind. That would be the most logical explanation. Jeff, I agree with everything that Jeff said on Mars, but there was some major omissions there. Mars was very wet in the beginning of its history. I talked about that. We know that for about 1 to 12 million years, right after Mars formed 4 billion years ago, it was 4 billion years ago, it had oceans and lakes. We have sediment layers that have been uplifted from asteroids. And we pretty much now know the history of Mars. It used to be a mystery. People always would say, where did the water go? And we know now that there was 3 reasons that Mars is very dry now and where the water went. The first one, when Mars was very young, it had a magnetic field, and Jeff didn't talk about that. I'm sure he knows it. And that magnetic field would have protected the atmosphere of Mars for a while. The magnetic field collapsed very quickly, and without a magnetic field, the solar wind was able to blow away the atmosphere and blow away the moisture. The next one was called the carbonate catastrophe. Hugh has a page on that in his book Improbable Planet. And what happened, obviously, is because there's no plate tectonics and there's no carbon cycle on Mars, when the rain mixed with the atmosphere, it made carbonates. That carbonates are in the soil. We can find those carbonates, and that pulled water vapor out of the air and helped Mars lose its water vapor very quickly. And the last one Jeff described very accurately, that the size of Mars is so small it couldn't hold onto its atmosphere. But it wasn't just the size, it was also the lack of magnetic field and also this carbonate catastrophe. And because of those 3 things combined is why Mars lost its water so quickly. Right? It wasn't one thing, it wasn't 2 things. It was hit by three catastrophes: its size, its carbonate problem, and the loss of magnetic field. And so those 3 factors together just doom Mars to be very dry very quickly. 1 million to 12 million years, the water's all gone.
Thanks, Dave. Dave's going to be giving a presentation here on the 31st of March. I was going to say Mars. March. And it'll be a Seder potluck. So plan on being here for that. And folks online, hope you can watch us too. Any other questions, anybody?
I got one other statement I need to say. Oh, go for it. Forget the questions. I believe I agree with everything that Jeff said, like I said, and I also agree everything that Fuzz said. But again, there was a couple omissions and things that people could be confused on that need to be clarified. Every time scientists talk about early humans, they always do this out of Africa, and it was interesting that Fuzz did that also, right? And he kind of contradicted himself because he talked about Adam and Eve, and we know from the Bible that that's Mesopotamia, right? That's the Euphrates, the Tigris River. But then in another sentence he said, that humans migrated out of Africa. And so there's a lot of confusion about that people think that the out of Africa scenario given by scientists contradicts the Bible, but it doesn't. And Fuzz used both those phrases, which I thought was interesting. He talked about Adam and Eve as literal, and the Bible's literal, and then in another sentence, he uses the standard scientist language of out of Africa, right? And people think that's a contradiction, right? But what's the name of this class? And what is a paradox? A paradox is something that's, we need to define that. It's our class. Everybody should know this, right? A paradox is where you have two things that seem like contradiction. It sounded like Fuzz contradicted himself. He talked about he believes in a little Adam and Eve, which we know is what is now modern day Iraq, is Euphrates and the Tigris River, and yet in another sentence he said humans came out of Africa, right? So is that a paradox, right? Did Fuzz contradict himself? No. He had a paradox, right? And so the solution to this paradox is you cannot use the maps of today to describe humans 100,000 years ago. And if you take out the time frame, you can have lots of paradoxes if you don't put the frame of reference correct, right? And that's what Hugh always taught. Always in this class, he's talking about before you talk about something, you describe the frame of reference, right? And if you get the frame of reference wrong, you can have all kind of paradoxes in the Bible. And the paradox there is 100,000 years ago, we were in the middle of the most severe ice age in the history of Earth. The most severe ice age in the history of Earth. This last thing, that's the Hugh's book. I pushed that one, obviously, is Surviving Weather and Climate Change. And Hugh goes in detail about how 100,000 years ago, we were in the midst of the most worst severe ice age in human history. And that ice age put all this, miles of ice, on the poles and on Greenland and the Himalayas, and the oceans were like 300 feet lower. For contrast, here in Los Angeles, we're 26 miles from Catalina Island. 100,000 years ago, during the most severe ice age, it was only 4 or 5 miles. The Native Americans were able to, they weren't 100,000 years, but they were 15,000 years ago, were able to just take canoes there, obviously, they didn't have to venture. It was so low that obviously when he talked about the Philippines there, and the people migrating to the Philippines, you could have walked again from Thailand to the Philippines, or some of the other islands taking just the canoe, because it'd be just a few hundred miles. And so likewise, this paradox of out of Africa versus Adam and Eve is there was no Red Sea. That you could walk from Africa, to the Middle East because they were connected. There was no Middle East and Africa. It was one continent, right? And so when we say out of Africa, West Africa and the Middle East are the same thing 100,000 years ago. Thank you.
Great point, Dave. Robert, did you have a question? I'll bring it to you. Hang on.
Could you expand and extrapolate a little bit more on the 3 gases about how toxic people that think that there might have been microbial life?
Yeah, you had a very good question. So just a moment ago, he asked the question. There's been a lot of scientists saying, well, we can't have life on Mars now because of the thin atmosphere and anything, the little bit of moisture that is on Mars is frozen. And so they've been postulating, obviously, it could be warmer under the surface of Mars, and there may be some little bit of liquid water under the surface of Mars and its crust, and couldn't life possibly live there? And that was a good theory if we go back maybe 20, 30 years ago. But we have so many robots now on Mars, and they've studied the soil not just in one spot, but I showed the map of all the different landers. We've studied the soil now over a dozen places, and we know that the Mars soil is just 100% toxic. If you were to take, a piece of it, I mean, all of us have eaten carrots with a little bit of dirt on it, or other food with dirt foods. I mean, my kids were little, they would drop something in the dirt and pick it up and eat it, and you're not going to get sick. On Mars, the soil is so toxic, if you got that soil in your mouth, it would poison you, it would kill you. There's sulfur in there. Hugh talked about that just last week. But what he didn't talk about also is there's toxic salts in there. There's chloride in the soil. And so the Mars soil is just really toxic. You can't grow anything in it. If you were just to put some bacteria in there and add some water, it couldn't survive. The pH of the soil is so bad, it's like baking soda. So if you did take that moisture that soil and put a little fertilizer and add some water, what would you get out of there? You again would have gases leaching out, and it would just toxic. You can't grow things in baking soda. Go home, get some baking soda, mix a little fertilizer in it, and try and grow something. It's just not going to work. And the Martian soil is just very toxic, and that's all the way through its crust. Its crust is quite deep, and it's all this sulfur, chloride, salts. There's basalt. There is volcanic rock there that's not toxic, but that's all mixed in with this other stuff. So the Martian soil is just very toxic. Yep.
Okay. Norm, 1 second. I'll just make a comment. On the cord and string section of the video, why was that important? I mean, especially the last part, the little half centimeter by half centimeter piece of cord that the Neanderthal may have made. Well, the reason it's important is we don't have any evidence that Neanderthal made things that technically advanced as a braided string. So if you accept that, you're saying that they have the same image of God that we do. And so that's why it's important to bring that up. And Fuzz told you the reasons that it was probably not accurate. The amount of lignin and cellulose present. Probably used photoluminescence to measure it, because it's too little to do carbon-14. You would have lost the whole thing. And photoluminescence it's got a reputation of not being very accurate. So there's a lot of things about Neanderthals. There's a lot of archaeologists, physical anthropologists that want to declare Neanderthal our cousin, the same species we are. And so that's why it's important, that little piece of string. Yeah, Norm, you want to say something, Dave?
Yeah, I have a totally different take on that. And that's because Fuzz has written books on human exceptionalism. And so he was coming from a human exceptionalism position. Hugh and I would look at this more from a biblical perspective than looking at it strictly at scientific human exceptionalism. I talked about this a little bit when I talked about my bird study. The Bible describes a life here on earth in 3 levels. There's pure physical life, that would be our bacteria or insects, reptiles, amphibians. And these are animals that exhibit either absolutely no personality, very little bonding at all. They don't make really great pets because they're not going to snuggle up with you and rub your head. The second one is nefesh life, or sometimes translated as soulish life. These are animals that bond to one another, and they bond to humans. And that's going to be our birds and our mammals, which is why they make wonderful pets, right? I brought my bird, I have the pigeons that doves that I've raised, and they're very bonded to me. They want to be with me. They want to please me. We all have cats and dogs, a great example. I don't have to go about the bonding there, right? We have dogs and horses that are willing to give their life for you because they love you so much. And then lastly, okay, I'll wrap it up right here then. And the last one is spiritual life, which is humans. And the Bible describes them not as tool makers, but as people that worship. And so I don't care how intelligent you find an animal or bird, they're not to get together on Sunday and worship God. They don't think about heaven. And so tool use is not the definition of the Bible. And so we know that crows make hooks I talked about. And so tool use is not what makes humans humans. It's our spiritual ability to desire to worship and to please God. And so we don't find these things. So when we find animals making tools, it doesn't bother me at all because that's not what the Bible describes us as. You want me to close in prayer then? Yes. We're out of time. I'll be happy to answer questions. I'll be here after class. I'll be happy to answer questions. That's one of the. It was very recent because those channels was a recent discovery, so I know it's within the last year. What? Oh, he's looking it up. Yeah, it was very recent because these channels were really recent. Those were recent satellite photos, so I know it was within the last year. Oh, the rope. Yeah, the rope. I don't have an answer for that one, but he's looking it up. All right, let me close here in prayer. Dear Lord, we thank you that you loved us so much to create this wonderful universe for us to live in. It doesn't matter whether we look at the entire universe or a single atom. We see your handiwork there in producing this wonderful place for us to live for this brief period of time. But I look forward also to the new creation where there'll be no more pain, no more suffering, no more tears, a wonderful fellowship with you and with other believers. We know that your Holy Spirit is out there convicting people of sin and their need for your forgiveness. We thank you for sending your Son, Lord Jesus, to teach us about love and forgiveness and the kingdom to come. May we not harden our hearts towards you, but may we listen to your Spirit and worship you, the Creator, and marvel at what you have made. Bless you and bring him back to us safely. Amen.